Hello everyone, in this video I'm going to solve 4 different quadratic inequality questions. But let's remember first steps of solving quadratic inequalities. Okay, first step is solve the equation. If an inequality is given like that, at first we are writing this one as an equation. Second step is find the critical points. If you solve this equation, you're going to get x1 and x2. These are going to be roots of this quadratic equation. And so here, these are critical points for inequality. And third step is draw the sign chart or number line and put the signs on the number line or sign chart. And the last step, write the solution set. Okay, let's see with the example. Okay, the same example again. Here, at first we have to write this one like an equation. X squared plus 3x minus 4 equals 0. Okay, how can we solve this one? We can solve this one by factorization method. Okay, now let's find two values. For example, which numbers can be here? Minus 2 and 2 can be. And also minus 4 and 1 and 4 and minus 1 can be. These are products of minus 4. Okay, if you multiply them, you're going to get minus 4. But some of these numbers should be coefficient of x, as you know. So this pair cannot be. What about this 1 minus 4 plus 1? Cannot be. And 4 minus 1 is 3, so we have to take this pair. So the products will be x plus 4 times x minus 1. Minus 1 is equal to 0. Then x plus 4 is 0. X plus 4 is 0. Or x minus 1 is 0. And from the first one, x1 is minus 4, first critical points. And from second one, x2 is 1. Okay, these are our critical points. And the next step is drawing a sign chart. And we're drawing sign chart. Okay, this part represents values of x from minus infinity, and we're writing critical points respectively. Minus 4 is first, 1 is second, and here plus infinity or just infinity, however. And here we are writing the equation, or this one, expression polynomial, x squared plus 3x minus 4. So minus 4 makes, these are zeros, the polynomial or critical points of the polynomial. And if you substitute minus 4 instead of x, so this one becomes 0. And if you substitute 1 also here instead of x, so expression becomes 0 again. What about other signs? Let's find out these signs. Okay. How can we get the first one? Actually, there are different ways. For example, we can get a line, we can get a number, which is greater than 1. For example, the number 2 can be, if you write the number 2 here, 2 squared plus 3 times 2 minus 4. Okay, 2 squared is 4 plus 6. Plus 3 times 2 is 6, and minus 4 and 4 cancel each other, so just plus 6. So if you substitute any number which is greater than 1, the expression becomes positive. Then this part becomes positive. And after that, we have to change the sign between the critical points, so it's going to be negative. So we can just put only negative sign, one negative sign, and here also we have to change this sign, so it's gonna be positive. Okay, you may try. For example, between minus 4 and 1, 0 is one number here we have. So if you substitute here 0 square plus 3 times 0 and minus 4, so it is minus 4. The sign is negative, as you see. The expression becomes negative. And here also, if you put another number, okay, let's put, for example, let's write minus 6 squared instead of x, plus 3 times minus 6 and minus 4, so it is 36 minus 18 minus 4. Okay, so it is positive, as you see. 36 minus 18, 18 minus 4 is 14, so it is positive. You can put any value here less than minus 4, so the expression becomes positive. And then the last step, writing solution set. How can we write the solution set? At first we have to check this one. What are we searching? What are we looking for? Okay, the expression should be greater than 0, just greater than 0. Okay, which parts are greater than 0? This part is greater than 0, and also this part is greater than 0. Here the critical points are not solution. If you substitute minus 4 and 1, the expression becomes 0. 0 is not greater than 0, so the zeros are not solution for our solution set. Okay, now how can we represent this case and this case? Okay, let's write here. So x is element of, okay, from minus infinity to minus 4 interval, okay, and union from 1 to plus infinity. Okay, this is our solution set. Okay, now let's solve this question again with number line, and let's see how to solve it. Okay, again the same question, x squared minus 3x plus 3x, sorry, minus 4, and the critical points are the same. Okay, I'm writing, okay, let's remember them. X1 is minus 4 and x2 is 1. Okay, I will skip the other steps. X1 is minus 4 or x2 is, okay, 1, right? Okay, sorry, 1, yep. Okay, then let's draw a number line. Okay, like this. Okay, let's take the critical points open. Why? Okay, because here we have just greater than, not greater than or equal to. The critical points should be open. We have to use open interval. Okay, now again the numbers should be respectively minus 4 and 1. Okay guys, here we can draw a shape, we can draw a curve like parabola. Okay, so if you think this one like a parabola, for example, if we have y is equal to x squared plus 3x minus 4, so the arms of parabola opens up like this. So because a is greater than 0, here a is greater than 0. Now here let's draw a curve similar to this parabola. Okay, similar to this parabola. Okay, and the arms open up, as you see. Now it is our parabola, as you see. Okay, now happy face here. And so the signs, this part, as you see, this part is on the x-axis. You may think this one like an x-axis. This part is on the x-axis. So at this part the expression becomes positive, and here the expression or the graph value of the function becomes negative, and here again plus on the x-axis plus. Okay, now where is the solution set? Where is the solution set? What are we looking for? Okay, let's remember again. So expression should be greater than 0. This part is solution set, part of solution set, and also this part is part of solution set. Okay, from minus infinity, this part is minus infinity, and this part is plus infinity. So again, we can write, as you see, the solution set. So x is element of the intervals from minus infinity to minus 4 and union from 1 to plus infinity. Okay, it's like that. Okay. Okay, what about the second one? Second one is again okay, second degree inequality, quadratic inequality. Okay, we are solving them. Okay, so let's write this one as equation minus 2x squared plus 3x and minus 1 is equal to 0. Okay, actually we cannot factorize directly this expression because the coefficient of x squared is different from 1. It is a problem for us. Then let's use this discriminant way. discriminant is equal to b squared minus 4ac, okay, discriminant is equal to d is equal to, okay, 3 squared minus 4 times minus 2 times minus 1, okay, discriminant is equal to 9, okay, minus becomes minus 8, nice, okay, discriminant is 1, okay, so here we have two different rules, as you see, it's two critical points then, okay, x1 is minus b plus okay, minus the square root of discriminant, I'm gonna take this one, over 2a, so is equal to minus b is minus 3, minus square root of 1 over 2 times minus 2, okay, this one is challenge, don't forget that it is not 1, okay, minus 2, so here minus 2 minus 3 minus 1 over minus 4 and minus 4 over minus 4, the result is 1. The first root is 1. What about second root? Just we have to change the middle sign here. So a minus b plus square root of discriminant over 2a. So just I will skip the other steps. So it's going to be minus 3 plus 1 over minus 4. So it, which is, okay, minus 2 over minus 4. Okay, so the result is minus 2 over minus 4, right? Okay, 1 over 2. Okay, if you simplify them, you're gonna get 1 over 2. Okay, the first one is 1 and the second one is 2, 1 over 2, I'm sorry. Okay, and then the other step is, okay, drawing sign chart. Okay, x, and our expression is minus 2x squared. Careful, we have to be careful here because the sign of leading term here, coefficient of leading term is minus 2, negative, so 3x and minus 1, and here, so minus infinity. Okay, let's write the critical points. The first one is 1 over 2, okay, respectively, and second one is 1 and plus infinity here. Okay, how can we get the first sign now? Yeah, okay, how did we decide on the previous question? Okay, so we put the number. Now for this one I'm gonna use the sign of x squared. What is the sign of x squared here? So it is okay, coefficient of x squared is minus 2, so the first sign on the right hand side becomes minus. Okay, it's our rule. If the sign of x squared is negative, the first sign on the right hand side becomes negative, and the coefficient of this one, x squared, is positive, the first sign becomes positive. Okay, you know this one, and the next sign becomes positive and the other sign becomes negative. Here we have to change after critical points, you know that. Okay, so what are we searching here? Less than or equal to 0. Here for this inequality, the critical points are also solution. Okay, solutions here. This one is solution, and okay, and negative parts are also solution. Okay, now let's write the solution set now. Okay, x is element of from minus infinity to 1 over 2. 1 over 2, it is closed. We're going to use square brackets. Okay, union from 1 to plus infinity. Okay, if we have less than or equal to or greater than or equal to, we're going to use these square brackets. Don't forget that. Okay, again, I'm going to solve this question with number line, and let's see how to solve it. Okay, I will skip the first steps. Okay, just I will write x1 is 1 and x2 is 1 over 2. x1 is 1 and x2 is 1 over 2. Okay, done. Okay, let's go on. Okay, number line, the next step. I'm writing minus infinity plus infinity, these symbols, and here we have to write the numbers again, 1 over 2 and 1. Okay, 1. Now let's remember this one. Here the function, the quadratic function is, if you think this one like a quadratic function, minus 2x squared plus 3x minus 1. So here a is less than 0, as you see. So the arms of parabola opens down like this. So it is sad graph. Remember, this one is sad graph. Then how can I draw this one? Again, I'm going to draw a shape like this shape. Like this parabola. Okay, how can I draw this one? Okay, like this. Okay. This one is 1/2. Okay, this one. Is it like a parabola? Yeah. Okay. Now, here as you see, the first part from 1 to plus infinity, it is under the x-axis, under the number line, so this part is negative, as you see. And here it is on the number line, so it's gonna be positive. And here this part is again negative. Okay, what are we searching? Why did I use this shape or this curve with like a square, like rectangle? Because we have less than or equal to. If we have less than or equal to or greater than or equal to, to write solution set, I'm gonna use this shape. But if we have less than or greater than, I'm gonna use this oval curves. Okay. Then here, what are we searching? Less than or equal to this part. Okay, also 1/3 is solution. You can see this one. And also 1 is solution. Okay, let's write x is element of from minus infinity and plus infinity. We're using parentheses, you know that. Okay, 1/2 and 1/2 is closed, and union. Okay, 1 is closed. Okay, and plus infinity. Okay, ready. What about the next question? Okay, easy question. We can factorize it. Okay, 5x squared minus 2x greater than or equal to 0. For this question and for the next question, I'm going to use only a sign chart. Okay, I will not use the number line. Okay, now let's factorize this one. Okay, let's write it first. The first one is writing equation. Sorry about that. Okay, 2x is equal to 0. Okay, let's factorize with x here. So 5x minus 2 equals 0. Then x is equal to 0, or this one is or, you know that. Okay, 5x minus 2 is 0. Then this one is actually clear. This one is first root. Okay, 5x is equal to 2, and x2 is second critical point is 2/5. Okay, now the sign chart. Okay, yes, so it is x minus infinity, and we have to write the roots or critical points respectively. Okay, the first one is 0 and the second one is 2/5, and here plus infinity, you know that. And here, okay, the expression 5x squared minus 2x, and here, okay, our zeros, and the first sign. Okay, the first sign, again, we're checking the coefficient of x squared. It is 5. That means the first sign is plus, and here minus, and here plus again. And here, what are we looking for? Greater than or equal to 0. Greater than or equal to 0. Let me use different color here. Okay, the blue one. Okay, this part is greater than 0, and also equal to 0 our solution, and 0 is our solution, and this case is our solution. Okay, from where to where? Okay, from minus infinity to 0, and from 2/5 to plus infinity. Okay, let's write the solution set. Okay, from minus infinity to 0. 0 is closed, don't forget that. Okay, union from 2/5 to plus infinity. Okay, and the last question again. Here the sign of x squared is less than 0, and less than here also the sign of inequality less than 0. Okay, nice, let's see that. Okay, here, if you cannot see this one, okay, you may use discriminant. If you cannot factorize that, okay, you may use discriminant, you know that. Minus x squared plus 2x plus 1 2 equals 0. Okay, now discriminant is equal to, okay, b squared minus 4ac. So d is 2 squared minus 4 times minus 1 times 2. Okay, here d is equal to 4 minus plus 4 times 2 8. Okay, so d is equal to, okay, 12. Okay, to make it easier, let's see what about square root of discriminant. Square root of discriminant is square root of 12, and it is 2 square root of 3. I'm gonna use this value. Okay, so x1 is minus b minus square root of discriminant over 2a. So careful again, sign of x squared is negative 1, not 1. Okay, so x1 is minus b is minus 2 minus square root of discriminant, I told that, okay, minus 2 square root of 3 over 2 times minus 1. Careful, I told you that. Okay, the second, first one. Okay, so if you factorize this one with negative 2 times so 1 plus square root of 3, and here we have minus 2, and simplify them, so x1 is just 1 plus square root of 3. So what becomes the second one? So x2 is equal to minus b minus square root of discriminant over, plus the square root of discriminant over 2a. So it becomes, actually, anyway, let's write. Okay, so minus 2 plus 2 square root of 3 over 2 times minus 1. Anyway, so again, let's factorize with minus 2, so it becomes 1 minus square root of 3 over minus 2. Again, cancel out them, so 1 minus square root of 3. The result is 1 minus square root of 3. As you see, the roots are symmetric. 1 plus square root of 3, other one becomes 1 minus square root of 3. Anyway, okay, now here let's do the sign chart. Okay, let's do the sign chart. Okay, here we have minus infinity, and first root, okay, this part is important. The 1 minus square root of 3 is less than 1 plus square root of 3. This one must be 1 minus square root of 3, and this one must be 1 plus square root of 3, and here plus infinity. Okay, and we are writing the expression minus x squared plus 2x plus 2. Okay, these are our zeros, and here the first sign of table is negative, because here sign of x squared is negative, and here becomes positive, and here becomes negative. We are going to change the signs, you know that. Okay, here let's shade the solution part. Okay, less than 0. Okay, less than 0. This part is less than 0. Also this part is less than 0. This case is less than 0. Okay, now let's write the solution set. X is 11, 12, from minus infinity to minus, not minus, 1 minus square root of 3. Okay, we're gonna use parentheses because we have less than 0, and here from 1 plus square root of 3 to plus infinity. Okay, this is all for this video. Okay, see you in the next videos. Bye bye.